Hello. Today we will be discussing about robot dynamics. So dynamics in general refers to time varying behavior. Robot dynamics is the time varying position and orientation of manipulator. During the work cycle of a manipulator, it must accelerate, move at constant speed and decelerate. This time varying position and orientation of manipulator is termed as dynamic behavior. The purpose of robot dynamics is to determine the generalized forces, that is to determine the generalized forces that is required to overcome the self-inertial loads. The self-inertial loads. So the inertia that is caused due to the weight of the links inside the robot. So the force that is required to overcome the self-inertial loads and also to produce the desired motion. Desired motion. So this is the purpose of robot dynamics. The purpose of robot dynamics is to determine the generalized forces that is required to overcome the self-inertial loads and to produce the desired motion. So let us see this through an example. Let us consider the task of arc welding. The robot needs to move the tool to follow a predefined trajectory. So the robot arms has to execute motions in order to carry the tool along that particular trajectory. So this requires a certain amount of work or energy that must be done to the robotic system. So the work done to the robot will not only overcome the self-inertial load of the arm, but also it will generate the desired motion to the joints of the arm so that the tool will follow its trajectory. Now, the question is, what should be the generalized forces that is applied to the robotic joints in order to produce the desired motion at the end effector frame? So let us consider a two-link manipulator where the position, velocity and acceleration of joint 1 is represented as theta 1 dot and theta 1 double dot. The same way at joint 2, right? So as we know that the velocity and acceleration will be propagating from one link to another link in this direction. So when the velocity acceleration are propagating, they will be causing some internal forces. They will be causing some internal forces to act on the links. So the force at the end effector, so that external forces acting at the end effector will be moving in this direction backwards. So the objective is to find the various forces acting on the system when the manipulator is moving and to find the torque which are acting at the joints. So a time varying torque represented as tau will be applied at the joints to balance out the internal and the external forces. So what are the internal forces? So the internal forces are caused by motion of the links. So say the inertial force, then Coriolis force, frictional force, or some of the internal forces. Then we have the external forces which are external force which are exerted by the environment. So these include the load and the gravitational forces. Load and the gravitational force. So we need to determine the various forces acting on the system when the manipulator is moving and then to find the torque, that is acting on the joints. So the torque, they are applied at the joints by the joint actuators. So we can represent this as tau equal to d of theta double dot. So this represent the inertial forces plus h of theta comma theta dot. So this is the centrifugal and Coriolis force plus c of theta. This is the gravitational force plus j transpose of F. This is the external forces. External forces plus frictional force, right? So the torque tau is represented by tau equals d of theta double dot plus h of theta comma theta dot plus c of theta plus j transpose of F. So we need to determine the torque tau in order to balance out both the internal and the external forces. The torque equation can be determined by two methods. One is Newton-Euler method and another one is Lagrangian-Euler method. Newton-Euler method is force based, that is, it is based on the Newton's law of motion, whereas Lagrangian-Euler it is energy based and it is based on the principle of least action, which means that is the Lagrangian, which is the difference between the kinetic energy and the potential energy, should be as little as possible for the object in motion. So the Newton's Euler method, it involves a vector function, whereas the Lagrangian Euler, it involves only scalar functions. The Newton Euler method, it is ideal for non-conservative forces, whereas the Lagrangian Euler method is not ideal for non-conservative forces. That is, this is because that no potential energy is attributed to the non-conservative forces. So both the formulations, that is the Newton-Euler and the Lagrangian-Euler formulations, they provide a closed form solution which are computationally intensive for making the real-time control based on such a dynamic model. So I can say that it is not impossible. I can say it is inefficient. The two approaches are inefficient. So in order to improve the computational speed, we also have recursive methods and the approximate models based on the simplifying assumptions are also developed. So these approximate models, they will result in only suboptimal dynamical performance, not optimal performance, which will just result in a suboptimal dynamical performance because of the assumptions that we make, and this will restrict the arm movement at low speeds. So next we will be deriving some the dynamics of some basic robotic